pleasant day to all of our viewers. Yuletide season is coming and we are about to take a short break in our studies and enjoy the rest of the vacation with our loved ones. But before that, join me as I present to you another fun and exciting topic in Grade 8 Mathematics. I am Mr. Timothy Acana and I am your online Grade 8 Mathematics teacher for today. Go get your modules and make sure you have your pen and paper with you. Today, I will teach you how to find the domain and range of a function. Then, we are going to graph and illustrate a linear function and its domain, range, table of values, intercepts, and slope. Before we start our lesson for today, let us recall the previous topic by answering the given activity entitled Function or Not Function. The directions for the activity are simple. All you need to do is to determine if the given is a function or not. Press the heart react button if it is a function. And if it is not a function, press the like react button. Let us start. First, we have 0, 5, 5, 10, 0, 15, 10, 20, and 0, 25. Can you determine if the given set of ordered pairs is a function or not? The domain is the set containing the elements 0, 5, 10. And the range is the set containing the elements 5, 10, 15, 20, and 25. As you have noticed, 0 appears 3 times as our first coordinate. Therefore, the given relation is not a function, since the x-coordinate should not be repeated. Did you press the like react button? That's great. Next, we have a given table of values. The values of x are 6, 9, 12, and 15. While the values of y are 2, 4, 6, and 8. Identify if the given table of values is a function or not. The given relation is a function since no element of the domain is paired more than once to the elements of the range. Were you able to press the heart button? Wonderful. Now let us identify if the given finite graph is a function or not. Let us identify the ordered pairs from the given graph. The ordered pairs are as follows. Point A, -1, 1, 0. Point B, 1, 1. Point C, 3, 2. And point D, 5, 3. The given relation is a function since each element of the domain is paired exactly with one element of the range. Were you able to press the heart button? Very good. How about the given line as shown in the figure? Is it a function or not? The domain of this graph is the set of all x such that x is an element of the real numbers, while the range is the set of all y such that y is an element of real numbers. Using vertical line test, if you draw a vertical line on the graph, it will only intersect the graph at exactly one point. Therefore, the graph is a function. Did you press the heart react button? Amazing. I hope you were able to recall how to identify the domain and range and to determine if a given relation is a function or not. Now let us define what is a linear function. A linear function is a function that can be written in the form f of x is equal to mx plus b, where m and b are real numbers. To understand more about linear function, let us answer the prepared activity entitled Input Output. All we need to do is to evaluate the following linear functions given the specified value of x. Let us begin. Evaluate f of x is equal to negative 2x plus 10 at x is equal to 3. We have f of 3 is equal to negative 2 times 3 plus 10. Then, f of 3 is equal to negative 2 times 3 is equal to negative 6 plus 10. And the value of f of x is equal to negative 2x plus 10 at x is equal to 3 is 4. Next, we have f of x is equal to 3x minus 9 at x is equal to 0. We have f of 0 is equal to 3 times 9, 3 times 0 minus 9. 3 times 0 is 0. Therefore, we have f of 0 is equal to 0 minus 9. And the value of f of 0 is negative 9. And lastly, evaluate f of x is equal to x plus 14 at x is equal to negative 6. We have f of negative 6 is equal to x plus 14, and f of negative 6 is equal to negative 6 plus 14. Negative 6 plus 14 is equal to 8. Therefore, the value of f of negative 6 is 8. Now let us refer to the given problem. A department store holds a midnight sale. All products are sold at 40% discount. The marketing supervisor consider a table of market prices X pesos and selling prices Y pesos for the shoppers. In the given table, we have the first column, which represents X as the value of the market price, and the second column represents Y as the selling price with a 40% discount. First, let us identify the ordered pairs of the given table, which are as follows. So we have 100, 60, 150, 90, 200, 120, 250, 150, and 300, 150. Then, we are going to solve for the slope of each pair of points. Let us solve first for the slope of the points whose coordinates are 100, 60, and 150, 90. Using the formula of the slope and substituting the values, we have m is equal to 90 minus 60 over 150 minus 100. 90 minus 60 is equal to 30, and 150 minus 100 is equal to 50. Simplifying 30 over 50, we have 3 over 5. Now let us solve for the slope of the points whose coordinates are 150, 90, and 200, 120. We have 120 minus 90 over 200 minus 150. 120 minus 90 is equal to 30, and 200 minus 150 is equal to 50. Simplifying, 30 over 50 is equal to 3 over 5. If you will notice, both resulting slopes are equal to 3 over 5. And if we continue to solve for the slopes of each pair of points, the result will still be 3 over 5. This indicates that the points lie on a straight line and represents a linear function. Now, let us create an equation of the line using f of x is equal to mx plus b, where m is equal to 3 over 5, and using the points 100, 60. Substitute m is equal to 3 over 5 and 100, 60 to solve for b. We have 60 is equal to quantity 3 over 5 times 100 plus b. Simplifying 3 over 5 times 100, that would be equal to 60. Therefore, we have b is equal to b is equal to 60 minus 60, and 60 minus 60 is equal to 0. Now we are going to find the equation of the linear function if m is equal to 3 over 5 and b is equal to 0. Substituting, we have f of x is equal to quantity 3 over 5x plus 0. Simplifying, we have f of x is equal to 3 over 5x. F of x is equal to 3 over 5x is an example of a linear function. Let us now graph the given ordered pairs from the table of values. If we plot and connect the points, this is what the graph looks like. Take note that the graph of a linear function is a straight line. Now, let us solve for the x and y intercepts of the linear function f of x is equal to 3 over 5x. To solve for the x-intercept, let f of x be equal to 0. We have 0 is equal to 3 over 5x. Multiplying 5 to both sides of the equation, we have 5 times 0 is equal to quantity 3 over 5x times 5. Simplifying, we have 0 is equal to 3x. And dividing both sides of the equation by 3, we have x is equal to 0. Therefore, the x-intercept is at 0, 0. To solve for the y-intercept, evaluate f of 0. We have f of 0 is equal to 3 over 5 times 0. Simplifying, f of 0 is equal to 0. Therefore, the y-intercept is at 0, 0. The x and y intercepts are both 0, 0, which means that the graph passes through the origin as shown in the figure. To determine the domain of this linear function, we will extend the line going to the right, and it will contain all positive real numbers. And if you extend the line going to the left, it will contain all negative real numbers. Therefore, the domain of this set, the domain is the set of real numbers. And in set builder notation, we have D is equal to all x such that x is an element of real numbers, or in interval notation, D is equal to the negative infinity to the positive infinity. In the same manner, the range is also the set of real numbers. In set builder notation, we have R is equal to Y such that Y is an element of the real numbers, or in interval notation, R is equal to the negative infinity up to the positive infinity. To further understand linear function, let us have some more activities. Given f of x is equal to 3x minus 1, determine the following. Slope provide table of values, show its graph, x and y intercepts, and the domain and range. First, let us determine the slope of f of x is equal to 3x minus 1. F of x is equal to 3x minus 1 is written in slope-intercept form. Y is equal to f of x is equal to mx plus b. Therefore, the slope is 3. Now, complete the table of values for f of x is equal to 3x minus 1. Evaluate f of x is equal to 3x minus 1 if f is equal to negative 1, 0, and 1. So first, evaluate f of negative 1. F of negative 1 is equal to 3 times negative 1 minus 1. 3 times negative 1 is equal to negative 3, and negative 3 minus 1 is equal to negative 4. Therefore, f of negative 1 is equal to negative 4. Now, evaluate at f of 0. F of 0 is equal to 3 times 0 minus 1. 3 times 0 is equal to 0, and 0 minus 1 is equal to negative 1. Therefore, f of 0 is equal to negative 1. And lastly, evaluate f of 1. F of 1 is equal to 3 times 1 minus 1. 3 times 1 is equal to 3, and 3 minus 1 is equal to 2. Therefore, f of 1 is equal to 2. Let us graph the following coordinates in the Cartesian coordinate plane. We have here the Cartesian coordinate plane. Then, we can now plot the points whose coordinates are negative 1, negative 4, 0, negative 1, and 1, 2. Then, we connect the points with a straight line. Now, let us determine the x-intercept of f of x is equal to 3x minus 1. To solve for the x-intercept, let f of x be equal to 0. We have 0 is equal to 3x minus 1. Using subtraction property of equality, subtract 3x to both sides of the equation. So we have negative 3x is equal to negative 1. And using multiplication property of equality, multiply negative 1/3 to both sides of the equation. Therefore, the value of x is equal to 1/3, and the x-intercept is at 1/3, 0. Now we determine the y-intercept of f of x is equal to 3x minus 1. To solve for the y-intercept, evaluate f of 0. We have f of 0 is equal to 3 times 0 minus 1, and 3 times 0 is equal to 0. 0 minus 1 is equal to negative 1. Therefore, f of 0 is equal to negative 1. And the y-intercept is at 0, negative 1. Here, we have the graph of f of x is equal to 3x minus 1, showing its x and y-intercepts. Take note that the x-intercept is also called the zero of the function. Lastly, we are going to determine the domain and range of f of x is equal to 3x minus 1. The domain and range of f of x is equal to 3x minus 1 are both the set of real numbers. And in set builder notation, we have D is equal to x such that x is an element of the real numbers. And in interval notation, we have D is equal to the negative up to the positive infinity. While the range in set builder notation is written as R is equal to all y such that y is an element of the real numbers. And in interval notation, we have R is equal to the negative up to the positive infinity. Let us have another problem. Determine the equation of the line passing through the points -1, -4, 5, -1, and 7, 0. And express the equation as a linear function. To determine the equation of the line, first, solve for the slope of the given points. First, we solve for the slope of -1, -4, and 5, -1. We have m is equal to -1 minus -4 over 5 minus -1. -1 minus -4 is equal, -1 minus -4 is equal to -1 plus 4, and 5 minus -1 is equal to 5 plus 1. -1 plus 4 is equal to 3, and 5 plus 1 is equal to 6. Simplifying 3 over 6, that would be equal to 1/2. Now let us solve for the slope of 5, -1, and 7, 0. We have 0 minus -1 over 7 minus 5. 0 minus -1 is 0 plus 1, and 0 plus 1 is equal to 1, while 7 minus 5 is equal to 2. Therefore, the slope is also 1/2. After solving for the slope, substitute m is equal to 1/2 and 7, 0 to solve for b. We have 0 is equal to quantity 1/2 times 7 plus b. Then, simplifying 1/2 times 7, that would be 0 is equal to 7 over 2 plus b. Therefore, the value of b is -7 over 2. Lastly, we find the equation of the linear function by substituting the values m is equal to 1/2 and b is equal to -7 over 2. So we have f of x is equal to 1/2 x plus -7 over 2. Simplifying, therefore, the equation of the linear function is f of x is equal to 1/2 x minus 7 over 2. For our third problem, from the given linear function f of x is equal to -2x plus 3, when x is equal to -1, 0, 1, and 2, find the range and show its graph. To find the range of f of x is equal to -2x plus 3, evaluate the linear function with the following values of x. So we have f of -1. F of -1 is equal to -2 times -1 plus 3. -2 times -1 is equal to +2, and 2 plus 3 is equal to 5. Therefore, f of -1 is equal to 5. Next, f of 0. F of 0 is equal to -2 times 0 plus 3. -2 times 0 is equal to 0, and 0 plus 3 is equal to 3. Therefore, f of 0 is equal to 3. Next, we have f of 1. F of 1 is equal to negative 2 times 1 plus 3. Negative 2 times 1 is equal to negative 2, and negative 2 plus 3 is equal to 1. Therefore, f of 1 is equal to 1. And lastly, we have f of 2. F of 2 is equal to negative 2 times 2 plus 3. Negative 2 times 2 is equal to negative 4, and negative 4 plus 3 is equal to negative 1. Therefore, f of 2 is equal to negative 1. Therefore, the range is y is equal to 5, 3, 1, and negative 1. And here we have the graph of f of x is equal to negative 2x plus 3, given the values of x is equal to negative 1, 0, 1, and 2. And for our last problem, if f of x is equal to x minus 7, and x is greater than negative 2, but less than or equal to 1, determine the range and show its graph. To find the range of f of x is equal to x minus 7, evaluate it when x is greater than negative 2, but less than or equal to 1. First, we evaluate at f of negative 2. So we have f of negative 2 is equal to negative 2 minus 7, and negative 2 minus 7 is equal to negative 9. Therefore, f of negative 2 is equal to negative 9. Next, we have f of negative 1. F of negative 1 is equal to negative 1 minus 7, and negative 1 minus 7 is equal to negative 8. Next, we evaluate at f of 0. F of 0 is equal to 0 minus 7. And 0 minus 7 is equal to negative 7. Therefore, f of 0 is equal to negative 7. Lastly, we evaluate at f of 1. F of 1 is equal to 1 minus 7, and 1 minus 7 is equal to negative 6. Therefore, f of 1 is equal to negative 6. Therefore, the range of f of x is equal to x minus 7 if x is greater than negative 2 but less than or equal to 1 is y is greater than negative 9 but less than or equal to negative 6. And here, we have the graph of f of x is equal to x minus 7 if x is greater than negative 2 but less than or equal to 1. We are almost done with our lesson for today. But always remember that the form of a linear function is f of x is equal to mx plus b, where m and b are real numbers and m is not equal to 0. The x and y intercepts of a linear function can be solved by substituting f of x is equal to 0 to find the x-intercept, also known as the 0 of the function, and by evaluating f of 0 to find the y-intercept. The graph of a linear function is always a straight line. If the domain has no restriction, the domain and range of any linear function f of x is equal to mx plus b, where m and b are real numbers, and m is not equal to 0, is the set of all real numbers. However, if the domain is restricted, the range is also restricted. And now it's time for the question and answer portion. Do you have any questions? Just type your questions in the comment section and we will try to answer it. For our first question, what is the domain and range of a linear function whose graph is a horizontal line? That is a great question. And the answer is a linear function whose graph is a horizontal line is called a constant function. And its domain is still the set of real numbers, while its range is the constant of the linear function. We have here another interesting question. Is it okay to leave our answer written in standard form, ax plus by is equal to c, even the direction says to write it as a linear function? Thank you for that wonderful question. And the answer is no. Since we are solving linear functions, we should always write our answer in the form f of x is equal to mx plus b. Thank you for your interesting questions. If I was not able to address some of your questions, you may just refer it to your subject teacher during your follow-up discussion. For your homework, kindly answer page 18 and 19 of your alternative delivery mode. Thank you for watching and have a blessed day.